everyone, and thank you for coming all the way. And hopefully the talk will be fun and you get to see something interesting. So my name is Vivek Ramachandran, and cool. So I'll be talking about APAD and EDR grade agent for Wi-Fi access points. And I'll come to what all of that means right now, right? Looks like a big alphabet soup at this point for people who haven't worked with EDRs. Now before we begin, a little bit of shameless self-promotion. So I started off as an electronics and communications engineer. I specialized after that in cybersecurity. I worked in a lot of companies. Cisco Systems is one of them. I was part of the team who created 802.1x and port security for the Catalyst 6500 series of switches, which is now obsolete, so I'm starting to feel a bit old now. After that, I went into security research. I figured that I enjoyed development, but I didn't want to remain a developer. So I went in and started breaking security. I spoke at my first DEF CON 14 years back, in DEF CON in 2007, if I remember. I broke web cloaking, I found a bunch of other attacks, and then I started loving that so much that I started doing security research pretty much full time. I won the Microsoft Security Shootout contest. This was the time when the term CTF had probably not even been coined or was just used in smaller circles. Moved on, started my own company. I've spoken at most hacker conferences around the world. I started a site many years back called securitytube.net and then eventually Pentester Academy. We teach over 15,000 professionals from 90 countries, from a lot of leading companies around the world. Now we have offices in India, US and Singapore. And we have Attack Defense Labs. I've authored a bunch of books. And I guess that's enough about me. So let's go ahead and look at the topic for the day. So Wi-Fi access points are everywhere. Is there anyone here who has never used Wi-Fi? One person? Okay, that's great. So Wi-Fi is pretty much everywhere. Wi-Fi is ubiquitous. You have it at your home, office, public places, and where not. Unfortunately, Wi-Fi security, especially in the end consumer space and the SMB space, has actually barely evolved. So I'm guessing everybody has a Wi-Fi access point at home, right? How do you figure out if someone has actually connected to your Wi-Fi AP and is actually using your home internet? Does your Wi-Fi access point have any kind of controls for that? Have you seen any logs specifically? So if you look at it, most APs unfortunately don't have much. The ones that do is very, very basic and very easy to read. Okay? So the point I'm trying to make is, even though Wi-Fi has been around for probably close to 2 decades, if not more, Wi-Fi security is still in the Stone Age. Nothing much has changed. Now, if you're interested in hardware security and you've done a little bit of firmware analysis and all of that, you would know that most Wi-Fi access points, just like IoT devices, end up using extremely old Linux kernels, end up using outdated versions of BusyBox and every other tool that is packaged, right? Along with that, there's unfortunately not much protection available as far as your APs are concerned. So mobile applications, mobile devices, I think after a couple of years we started seeing antiviruses and IDSs. None of them work, but at least we have them. As far as Wi-Fi APs are concerned, there's really nothing much. There's IP tables probably in there, but God help you if you consider IP tables as the only security measure, right? You have on your network equipment. So along with that, there's absolutely no good quality logging, alerting, none of that exists. So really, if you kind of look at it, how could you go ahead, have better security on top of layer 2 or layer 3, which is completely controlled by your Wi-Fi AP, which is completely broken? Can you build great security security on something which is already so unstable, insecure, and completely ignored? So the question arises, why has this not happened, right? I mean, is it really so difficult to build security into your Wi-Fi APs, consumer grade and SMB? I'm not talking about enterprise grade access points. They're really good. You can have it at your home if you can afford $500,000 for a whole setup. But if you can't, hey, this is all we have. Now, unfortunately, most hardware vendors hate creating good quality software. And the best example is what happened in the Android world, right? For many years, your mobile phone interface hardly changed. Apple came in, revolutionized with their iPhone. And then after that, Android came in, or rather Google came in with Android and said, okay, device manufacturers, you don't have to work hard. We'll take care of the software as a software company. You just make your hardware compatible, right? And that led to Android being where it is today. So hardware companies hate building software, or rather hate upgrading their software. And that is the same reason why I think in the hardware hacking village, the car hacking village, you're actually going to see a lot of vulnerabilities which are actually so commonsensical and outright stupid at times that you're wondering how is this available in a commercial device which is being deployed, right? So the core reason is just that. As simple as the reason is, hardware manufacturers don't like it. Now, the next question is, hey, what could go wrong? Has anything gone wrong? My home Wi-Fi seems to work. I've not been arrested so far, right? Things look good. Why bother? Like, Vivek, why do you have to take up this problem when it doesn't exist? So, unfortunately, just because, something bad visibly hasn't happened doesn't mean A, it's not happening already, or B, it can't happen. So what could go wrong? Now, your Wi-Fi access points on the Wi-Fi side completely control layer 2, right? It's layer 2 what you're going to connect over Wi-Fi. On the other side, it's layer 3 and then what goes out. If an attacker breaks into a Wi-Fi access point, he can control both of these depending on where the traffic is going. And this is really where just kind of put out a laundry list of items. If anybody is curious how this can be done, you can always talk after the talk. But DNS hijacking, traffic redirection, traffic modification, mangling, all of this is extremely easy. Now, once you compromise that layer, above that, going ahead and stealing credentials, using your Wi-Fi network, home network, as a pivot to try and break into other machines and systems, it's all very easy and commonplace. And attackers are actively doing it. Now, your system, depending on how much bandwidth you have, could actually be used to propagate spam. A lot of other crazy things can happen. We've even investigated cases, kind of helped law enforcement, where we found that somebody ended up watching things like child porn when in reality their Wi-Fi router got hacked and someone just forcibly pulled all their feed to their home router and then they get arrested, right? So keep in mind, do not take Wi-Fi security very. But people say, well, I've set my Wi-Fi WPA PSK passphrase and I'm secure. Nothing could be further away from the truth. Quick question, how many of you have changed your Wi-Fi router's ISP default password? So your ISP is actually set it. 6 people? Okay, 8. Others go back home and immediately change it. Unfortunately, a lot of these Wi-Fi routers are even misconfigured so that someone can access the admin interface remotely, which is actually true for most ISP deployed ones. That's the way they maintain or do maintenance cycles, right? So if you haven't changed that password, an attacker only has to know the default maintenance password for the whole ISP. He can find the entire range of IP addresses using the autonomous system number, scan, mass exploit, change DNS, whole laundry list as we have it here. So the key point that I'm trying to make is this isn't a problem which should be taken so lightly. So I teach Wi-Fi security, we teach a lot of stuff, and this is a common question I get asked. Hey, can something be done? Right? And just like MLK, I have a dream. Having worked in Wi-Fi security for over 18 years, I think, I would like to see secure Wi-Fi access points. Now, the fact remains, is this so difficult? So, what I'm going to be talking about is, can something be done? And what I'm about to talk about today is just to show you that the kind of security you're used to having on your servers and other places is something you could easily have vendors port in. If not, you could actually do it yourself. Right? And we will be releasing some code and start an open source project so that everybody can contribute. Question is, enterprise grade EDRs or server security, right? EDR, most people know it as endpoint detection and response system. The primary idea is you have some kind of an agent running, and that agent is monitoring for interesting activity from a security aspect. It ends up logging that activity in logs, and then those logs can be shipped and analyzed both for a single device as well as spatially when you have hundreds of devices in a premise and all of them are sending these logs. So this brings us to the core question. What are your devices really running? So if you look at almost, I would hazard a guess and say 90% of Wi-Fi devices out there probably run some variant of Linux. That's it. That's really all there is. The same is actually even for IoT devices. Now, what this means is we could do a lot of stuff just by doing what we do on a regular Linux server, porting it to that architecture. Now, one of the most popular open source distributions for Wi-Fi devices specifically is OpenWRT. Now, many manufacturers like ASUS, etc. might publicly say that this router supports OpenWRT, while many others might not. But they are actually using this in the core. So the best example is TP-Link. How many of you have TP-Link devices? Okay. So TP-Link, a lot of their code-based Wi-Fi ones are actually derived from OpenWRT. Okay? And if you download the GPL code available on the product page, unzip it, it's pretty much just that. Now, the next question arises, what is wrong with Wi-Fi security, or rather Wi-Fi platform security today? Now, if I told you want to run a Linux server in which you have a web server, you have a mail server, what would you tell me? You'd say, Vivek, okay, the best practice from the Stone Ages is principle of least privilege, right? I should ideally run every single daemon as a low privilege user. Maybe create one for each or assign it to an extremely low privilege user. Fair enough?
Fair.
Now, for people who haven't explored much, every Wi-Fi router out there actually runs everything as root. Which is crazy. Like, the same thing is also IoT devices. Now, a lot of manufacturers or a lot of software developers would have you believe that simply because it's too much work, or you get multi-user systems for free, right? The Linux kernel, every single thing already supports it. All you have to do is just make sure you set up multiple users, set up permissions right. Now, I actually dug up a little bit of conversation happening in the OpenWRT forums, where one genuinely curious security enthusiast ended up saying, hey, all processes running is root. I blanked out people's name. The idea is not to shame anybody. The idea is just to show you the state which everything is currently, right? Now, if you read through this, I know the font is a bit small, but if I were to give you a gist, I think if the gentleman is a developer or somebody part of the organization, not too clear, but what he kind of says is, you know what, the hassle is just not worth it. Like, what could anybody do worst case? Like, change your DNS, and if he's already doing it, well, why bother? So, I think a lot of times what ends up happening is the development community needs to be kind of told that, hey, this is not okay. It's very easy to have a multi-user system where you can have protection. Now, what do you actually need if you were to conceptualize a secure Wi-Fi router, right? So if I were to break it up, the first thing, of course, you would require is some kind of a secure boot process, where all the components loading are trusted, right? This is because an attacker or somebody in the supply chain should not be able to load a piece of malware or mal device or whatever, right? The next thing is OS security. This is really where you make sure you have the latest kernel, you patched everything down, you locked everything down. Most of it is really commonsensical. I kind of feel stupid just repeating it, but hey. And then application security, right? Again, we all know the do's and don'ts. We've read like innumerable documents on these. Now, why secure boot? Why should a manufacturer go ahead and lock up some of the boot process and make sure only trusted components can load? I'll give you a very simple example. If somebody wanted to backdoor hundreds of home routers, the only thing he'd have to do is purchase those 100 routers from Amazon or whatever is the local e-commerce site, flash his backdoor firmware, and pretty much just return that. They go back on the shelf, someone else is going to buy it. Even worse, someone could go ahead and buy 1,000 routers, backdoor it, put it back on Amazon or wherever, and offer it at a discounted price. 30% low. I think I was talking about this in the training as well. How many of you would not buy a router which is being offered for less? There are many, many variations. It's probably holiday season. You end up getting a shiny new router as a gift for being a valued customer. And most people end up probably using, one or more core services like, infrastructure provider, and you can just say, hey, as Amazon, we really value you as a customer, here's like a little gift. So, getting into people's homes is unfortunately more easy than we kind of realize. The same is with IoT as well. Now, unfortunately, once someone plugs in, let's say, your backdoor router, it's easy for the attacker to even know where you live. And this is a common fallacy people have. They say, okay, maybe he gets to my internet, how do we figure out? Do you notice on your phones, they actually, the phone prompts you saying if your Wi-Fi is enabled, it can still figure out your location? So what typically happens is Google and large companies like Apple have ended up collecting the list of Wi-Fi access point SSIDs and VSSIDs and created a huge geotag repository. They even have a public API you can use. This is not something secretive. You can go and use Google's location APIs. So an attacker could go ahead and install such a device and have it quickly scan the neighboring APs, get the list, use this API, pinpoint your home location. Okay? So do not think that IP address is not going to give away where I exactly live. He's not using your IP. He's actually using the list of neighboring APs that he can scan. So a lot of this can get sinister. We've seen cases where people have been stopped, people have been monitored, important people's credentials have been compromised. So we've looked at many of these things over the years, and that is really where secure boot is so important. Now, just to give you a breakup, primarily you want the bootloader to be trusted, which means eventually maybe you'd like a security chip which can ensure that the bootloader is signed and all of that stuff which you see on your phone. I do understand and appreciate that for some Wi-Fi routers, especially the really low-end ones, it's a bit difficult to package that in for the price points being offered. But I at least appreciate having an option all the way up to the SMB range to get something like this, right? Which doesn't exist today, at least to the best of my knowledge. Now, the bootloader in turn loads the kernel, device-free binary depending on the architecture of booting, loads that. The kernel, once it completely boots, loads all the drivers, mounts the file system, and after that, control is passed to the init process, and the init process ends up running whatever you've mentioned in init D or whatever. So this is the whole boot process. Just checking on the time. 15? Okay, so chain of trust, trusted bootloader, as I mentioned, trusted kernel, trusted apps. As far as OS security is concerned, once again, what really beats me is why people do not have firmwares in which kernels enforce module signing. Comes for free. How many of you have ever installed a piece of software in your Wi-Fi router? I would assume your Wi-Fi router is completely baked, right? You have the router that's running. Why can't a manufacturer literally even completely remove kernel loading, module loading? You can actually disable it. There are workarounds. However, for most attackers, it's going to be difficult. There's no need. How many of you have loaded a kernel module on your Wi-Fi router to make it work? No one. Right? Why keep it open? Why not enforce signing and things like that? So, this is really where what we are going to kind of talk today, and I'll show you a quick demo, is what I've tried to do is show you it's relatively easy to actually write security modules which can run as part of the Linux kernel on the Wi-Fi router. So I have a small home-grade router, the AR750. The same actually applies to pretty much most Linux routers. Show you a demo of that. At the user level, many things can be done. Principle of least privilege. I was quite surprised to see that the OpenWRT build system by default did not include namespaces and C groups. So namespaces and C groups are the same kernel feature which facilitate isolation technologies like Docker and Kubernetes and whatever you use. Right? Comes for free. It's not something you really need to kind of spend too much time integrating. Okay, so now I'll actually show you a quick demo. So APAD, access point, attack detector and prevention. I don't have a P in there. So a beginning. The reason I mentioned this is I've written 3 simple modules to show, illustrate, make it open source. We'll start doing a project after that. So the whole idea is, can we detect attacks and can we go ahead and log things? So let me go right into the demo. Okay. So I'm going to type with one hand. You're going to see a lot of typos. So this is the Wi-Fi router that I have. I'm going to log into the router. Oops. Okay. I think screen isn't showing. Change my. Give me 1 second. So I've logged into my Wi-Fi router, and what I've already done is loaded the kernel modules. Now let me explain what each of these modules do. So something typically an attacker might do is, try to run a remote network scan, right? Try to fingerprint what is there. Now, in a typical attack, a Wi-Fi router, if you look at the interface, an OpenWRT, in my humble opinion, probably provides a more detailed interface than most routers out there. I have a super secure password, as you can see. I'm following best practices in the Wi-Fi security world. So if we actually go in and look at the system log, actually find this just a basic system log, that's about it. It's kind of given me, I logged in. Now let me run an Nmap scan remotely on the router. So what I'm doing is, from my VM, just run a simple Nmap scan. On the Wi-Fi router. Scan is already running. Hopefully the demo gods are kind. There you go. Right? So I can see SSH is open, domain is open, blah blah blah. Now if I actually go back in here and I do a quick refresh of the syslog, do you see any other information which actually says that you've been scanned right now remotely by an attacker? There's nothing in there, right? Okay, let's look at the other log the router gives. And honestly, most routers do not give you a system or a kernel log. They just give you a very basic boot log. So let's actually go in here. Okay, do you see anything in here which tells you you've been scanned right now? So now this is really where the first demo is me creating a custom module which leverages a filtering framework and routing framework called NetFilter. It's part of the kernel. How many of you use IP tables? Anyone? IP tables? Okay. IP tables internally uses the NetFilter framework to do everything. But instead of using the user space utility and trying to write out a crazy number of rules and all that stuff, I'm leveraging the actual kernel feature set, NetFilter. And what I've done is, I've gone ahead and now this is a very simple demo. The whole idea really is just to show you this can be done. So what I've done is I've created a simple in NetFilter patterns, they call it a hook. What I've basically said is, hey, any packet destined for the Wi-Fi router, local in, make sure that if it is an IPv4 packet, I need to check it. Okay? So any packet coming in, I'm actually going to go ahead and check it in my function. And right now I actually do a very simple check to see if this is a TCP SYN packet to detect SYN attacks. You can extrapolate it as much as you like, create a full-blown detector. So after we compile it, load it on the device, so let me go ahead. I'll skip all the compilation and all that part. So I'm just going to do a very simple insmod network scan detect. Okay, visibly nothing happened. If I do an ls mod to look at the list of modules, we can actually see the module has loaded. Now I go back. And let me rerun the remote scan. Let's actually go back here. So the scan is running. And now, you notice it's actually detecting the scan. Don't I deserve a clap? Let's give it. Clap if you want. So the key thing is, notice that this is basically what it's checking is incoming SYN packets. You can have a very detailed state machine which can detect a lot of scans, right? My idea with the APAD is just to show you this can actually work. If you even go ahead, once I release the code after the conference, you can actually install this on most routers by using the compile toolchain. And you will notice there's hardly a hit to the overall performance, hardly any delay. Now, I have used NetFilter. There are more modern techniques which can be used depending on the kernel version the router supports and all of that. So just so that you're kind of complete from a knowledge angle, you could use the latest eBPF to go ahead and install and hook packets at a much more lower level, XDP and all of that, newer technologies, LSM and whatnot. Unfortunately, most of your Wi-Fi routers still don't have the version of kernel supporting it. So what I've done is I picked up something which will work even for extremely old kernels. Okay? So you can clearly see the Wi-Fi, the network scan got detected, and this is directly in your log. Now, the next part, of course, is this automatically goes to some kind of a logging server, and you immediately start getting alerts in your SYN product, ADN board, ELK, whatever you kind of use, right? So that's that part I'm leaving out. There's nothing really to show there. Now, the other thing I want to kind of show you is a common attack. Is an attacker may log into the router and he may go ahead and do various activities, right? Like killing important processes and things like that. So the next thing I want to show you is monitoring different activities which are happening. I've used one syscall which is responsible for killing any process. And we'll be monitoring that syscall so that if someone tries to kill something, even use a root, it will be detected. Now keep in mind, to make this really secure, the idea is that I've already baked in this functionality into the kernel. The kernel is loaded, enforces signing, does not allow any other things to load. So even as a root user, if an attacker breaks in using a web vulnerability on the interface or using something else, even as root, the attacker might not be able to do certain things, right? So Linux has other things like capabilities and whatnot with which you can even kind of make root less powerful if you wanted, but I leave that for you to research. So I'm going to go ahead monitor killing a process. So I'm going to insert the module, and or rather let me just first show you a process which is started and killed and see what happens. Started a simple tape process in the background. Let's find out the process ID. And we see that the process ID is 1640. Kill 1640. Fair enough, got killed. Now, typically in any security system, something like this should trigger a log, which should eventually go ahead and go to your EDR aggregator or wherever. Of course, nothing like this exists in the kernel by default, nor does it exist in any Wi-Fi router. So now what we're going to do is, I'm using the syscall hooking technique, and we hook the syscall table. I'm just going to open up the code briefly and show you.
Cannot see the thing.
So I'm actually going to show you the prevention one first. So very simple, it's kind of been a technique around for a very long time, which is you find the syscall location, you find the offset of the syscall you want to hook, and then you point that to your own function, which will get called anytime someone tries to kill something, and in that you would primarily go ahead and log things, or you may even do an accept or deny, allow, don't allow, right? All of this code is going to be released for free. You can take a look at it later. Just want to make sure that you understand this is custom code and not something which is already available. Okay, so now let me actually do an insmod, and the first demo is kill monitor. Now all this does is anytime any kill happens, it will monitor and log it. Okay, you could extrapolate this pretty much for any syscall. It's quite easy to do it. Okay, so I have this running as well. So the kill monitor is running here. Now, if I go in, start the process again, let's find the process ID. Typing with one hand is difficult, so apologies. And then try to kill it. It will be killed. Fair enough. But now if we go back, your Wi-Fi router is starting to monitor it. You see that? So it's actually saying there is a kill attempt on this PID by this PID. So the idea is just like an EDR system, you can log literally any activity happening. It's not much effort at all. And that's really what I'm trying to drive home here, is in your Wi-Fi router, you can have a security system just as strong and powerful as on a Linux server or a good endpoint. Notice we also detected 2 incoming SIMs on port 80. I actually did a page refresh, so that started a new TCP connection, right? Maybe couple. Now, let's actually look at protecting processes. So on Windows and other systems, we have processes whereby you cannot kill the process. You see that? The process is at a higher elevated level and you can't kill. So simple demo in which now you cannot kill a certain process, even if you're root. Now keep in mind, the assumption is our modules have been pre-installed, signed, and no other modules are allowed to load once the Wi-Fi router starts. Which I think is pretty fair because the manufacturer controls the initial firmware, right? So if an attacker breaks in, he already has to live with what the manufacturer has installed. Fair enough? So now, I'm going to go ahead and first remove the module I just installed. So let's do remove kill monitor. And let me go ahead and run kill prevent. Got copy pasted. It did. So what this has done is it's installed a kill prevent kernel module which I have written, and it basically says, it's a very trivial demo, basically says any process with the name tail, do not allow to kill. You're not allowed to kill it. Okay? So kill 9, nothing should work. And this is, let's say in your Wi-Fi router, we actually create user space processes which are actively sending to the syslog server, right? You don't want the attacker to immediately come in and start killing those processes. You don't want him to tamper those processes. Fair enough? So now, let me once again start the kill process. Let's figure out its process ID. And now let me try to kill it. There you go. So now, I'm even using -9, not permitted. And if we were to go ahead and remove our kernel node security monitor or preventer, whatever you want to call it. So let's remove it. Now try to kill it. Kill it. So the key thing I'm trying to convey here with these 3 demos is, in a typical EDR server security which is actually running kernel mode, you need a way by which you can monitor every activity happening on the system, right? Kill, process creation, sys trace, gazillion other things, right? Which a typical EDR does. So what I'm trying to show you is, you can pretty much do the same thing on your Wi-Fi router. Right? Only thing is you have to spend more time maybe writing more code, but hey, those companies are collecting a good amount of money when they sell you a Wi-Fi router. Right? I didn't get paid to do this, I'm just kidding. But so you could go ahead and create an elaborate system. The second is network attacks. So let's say an attacker is trying to break in remotely. The early signs that there is a network scan, somebody is trying to connect, somebody connected, all of that can be easily logged. So you could immediately know, your Wi-Fi router could go ahead and immediately, alert and say, hey, you're going to be attacked. There could be a little red light on top of it. You can just start glowing. Actually, you could make it yourself. Right? Connect to the serial port. We have a hardware hacking village. You connect to the serial port, something happens, this kind of good. But the point I'm really trying to make is, the kind of security you're used to seeing on server sides, endpoint EDRs, it's relatively easy to bake in to embedded devices, including to some extent IoT devices. Right? Not difficult at all. And what really, beats me, of course, everybody tries to be like, it could be costly, or there could be like a huge overhead. There isn't. Try running tests. I've run tests on most routers and these modules run hardly any. And as I said, if you have routers with newer kernels, you can then leverage eBPF, LSMs, and all of that stuff to make this even more faster. So, I think really what's been happening so far, but I'm going to go back here, is vendors have been giving excuses. How much time do I have? 2 minutes? So what is the policy when somebody like overshoots you? Drag them off stage or? Drink? Half? Accepted. Okay, so I'm just going to show you one last demo, which is, if you want to play with this on Attack Defense, you made this completely free. You can go inside and click on Community Labs. It's completely free. And what we've done is we've emulated a Wi-Fi router in a container using UU. And that will allow us to go ahead and look at exactly what we've done. So all of this is free. Just go in and click. So I've started the lab. we go into the lab. So now all I'm doing is, now I'm going to go ahead and run a kernel, and actually a full-blown Linux system, which is OpenWRT, using emulation with QEMU. So my team, who many of you met like in the training, they've worked very hard to get this ready for ROOTCON. So it's literally like a Linux system boarding up. There's no real difference. And once everything is loaded, you can see this is OpenWRT. And now let's say I add in small. Let's do the network scanning one. What I'm trying to show you is the same thing. We could actually emulate and test literally in a lab environment, with the browser. So now let me just do an nmap scan. Now. So I don't have network connectivity with this one from here, so I'm just going to show you that the whole thing kind of like works. And you can do the same kind of protection. This is if you want to play with what I've just shown without having to buy a router. Okay? Alright. So I think last couple of points which I want to make is, if you cannot go back here. So as you can clearly see, all of this can be easily solved, right? You can go ahead, of course, easily update to the latest kernels with all the patches. You can create security solutions which can monitor devices pretty much all the time. Whether it is monitoring activities happening on the device or happening to the device over the network, as you've seen. And I guess manufacturers need to start thinking more about how they can build security from the ground up. The assumption in all my demos is we are the manufacturer, we have installed a piece of firmware which already contains our security modules. Again, this is not really an assumption, this is a requirement for any security product to work, right? I mean, EDR or anything. Cannot work on a compromised system. The assumption is that T equal to 0, you have a system which you secure with your utility, and then attackers can go ahead. Now, most of this is POC, which means there are ways by which you can still beat it, but it's quite easy to create something elaborate. So what we are going to do after the conference is release an open source project on GitHub. I think on the slides we'll update it and give it to ROOTCON. So when you download the slides later, you'll know the GitHub project name. I would love to have APAD, but 4 letters are pretty much taken everywhere for domains and GitHub accounts. So I don't think I'll get it. And over there, me and my team, we initially planned to go ahead and create a much more elaborate framework. This is just the beginning, and anyone can contribute. That's all from my side. Thank you so much. It's great being here. Thank you.